Good morning, children. Today's topic is atmospheric pressure. In the last class, we had studied that liquids and gases, they can flow, so they are known as fluids. We can call them as fluids, right? And they have weight, so they exert pressure. The envelope of air that is around us is known as atmosphere. It extends many kilometers above and it consists of many gases like oxygen, nitrogen, hydrogen, etc. All gases, they have weight, so they can exert pressure, and they exert pressure in all directions and on all objects around. The pressure which is exerted on object by the weight of the air above is called atmospheric pressure. And this atmospheric pressure varies with the height of the object. If the object is at sea level, there the amount of air is high. So the pressure will also be high. The atmospheric pressure will be more. But as the altitude increases, then what happens? The amount of air decreases. And as the amount of air decreases, the weight will also decrease. Hence, the pressure will also reduce. So, at high altitude, the atmospheric pressure is less, while just above the sea level, the atmospheric pressure is high. And barometer helps to measure atmospheric pressure. Children, we are all surrounded by air. All around us, air is present. Air has weight, so it exerts pressure on us. But we are not able to feel that air pressure. Why we don't feel this air pressure? Because of the fluids that are present inside our body. Both air and liquids are present inside our body. They also exert pressure, right? And they balance out the air pressure of the surrounding. In fact, the pressure inside our body is slightly higher than the pressure outside. That's why we are not able to feel that air pressure that is from outside. We will only feel air pressure when we encounter an imbalanced air pressure between our body and the surrounding. Why do mountaineers usually suffer from nose bleeding at high altitude? Children, you know that the amount of air is less at high altitude. If amount of air is less at high altitude, the atmospheric pressure also becomes less than the pressure which is exerted by the fluids that are present inside your body. And due to this difference in the pressure, the capillaries or the blood vessels that are present in your nose, as they're very thin, they burst and they start bleeding. Some application of atmospheric pressure. You know that air is present all around us, so it is exerting pressure, right? And some of the activities are possible because of this atmospheric pressure. You all drink juices with the help of straw. Any juice or any liquid or water, if you take or you drink it with the help of straw, then the first thing what has to be done, the air has to be removed from the straw. Once the air has been removed, then this high atmospheric pressure acts on the surface of this liquid, whether it's water or a juice, it acts on it and it forces the liquid to move into the straw. So drinking with the help of straw is possible because of atmospheric pressure. The other example, this rubber sucker, right? This rubber sucker, when we fix it on the wall, then at that time the air out here is removed, right? So air pressure becomes less and the outside air pressure or the atmospheric pressure forces it to stick firmly on the wall. Now this rubber dropper and syringe also work because of atmospheric pressure. In this dropper, if you want to take out any medicine or the liquid from the bottle, this dropper is pressed and the air inside moves out. When air moves out, the pressure decreases and outside air presses the liquid to move into the dropper. Same happens in the case of syringe. First, the piston is pressed, due to which the air moves out, the pressure will reduce, and outside atmospheric pressure will force the liquid to move into this piston. Another application of atmospheric pressure, vacuum cleaner. Vacuum cleaner is used for removing the dust and the dirt particles. In vacuum cleaner, inside the vacuum cleaner, there is a fan which removes the air from inside, due to which a vacuum, partial vacuum is created. That means the amount of air reduces, so the pressure inside reduces. At the same time, the atmospheric pressure, which becomes higher than inside pressure, forces the air and the dust particle to move into this dust bag. Now these dust particles are trapped here, and the air which has come along with this dust particle moves out from here, right? So this way vacuum cleaner helps to remove the dust particles. Children, now you can try this activity. In this activity, you need to take water in a glass, cover it with a piece of cardboard, invert it, and then slowly remove your hand. And you will observe that this cardboard will not move from there and water will not spill out. Now, why this happens? Because atmospheric pressure is acting on this cardboard, and it is strong enough to support the weight of the water in the glass. So the water will not come out from here. Let's revise what we have learned. Envelope of air around us is known as atmosphere. It extends many kilometers above and consists of many gases. All gases have weight and they exert pressure in all direction and on all objects. This is called atmospheric pressure. It varies with height of the object above sea level. At high altitude, amount of air is less, so atmospheric pressure is also less. Barometer helps to measure the atmospheric pressure.